Hi, in this series of video lectures we're going to look at ways of integrating rational functions. Right, so remember, what is a rational function? A rational function is a function of this form, p of x divided by q of x, where p and q are both polynomials. Right. Now, there's a couple of simple rational functions that we already know how to integrate. Right, for instance, I've written 6 different forms here on the board. And each of these has a relatively simple integral. For instance, in the first case, the integral is just 2 over 5 ln absolute value 5x plus 7, of course, plus c. Right. In the second case, well, this is just 2x minus 1 all to the power of minus 7. Right. So the integral will be 2x minus 1 to the minus 6 times an appropriate factor. So we'll have minus 1 over 12 times 1 over 2x minus 1 to the 6 plus c. Right, so we have a half for the 2x and another minus 1 over 6 for that. That gives us minus 1 over 12. Right. And here in the third case we have integral of x over x squared plus 2. Again, that's a relatively simple one. It's a half ln absolute value x squared plus 2 plus c. Okay. In this case the absolute values aren't strictly necessary since the expression x squared plus 2 is always positive. However, just to be safe, I think we always write it, right, just in case we make a mistake and forget it somewhere. Right. Now the last one, well, this is actually also quite easy. Right? And what you have to do is remember that the derivative of arctan of x is 1 over x squared. Right. So if we take out the 9 here as a common factor, right, we get 1 over 9 integral 1 over, right, we're going to have a plus 1, right, because you take out the 9 as a common factor, and here we'll have 4 over 9 x squared, right, which we can write as 2x over 3 all squared, of course dx. Right. And this is now a familiar form, right? This is just the derivative of arctan, right? But instead of x we have 2x over 3. Right, so this will be our 1 over 9 times 3 over 2 times arctan 2x over 3 plus c. Right. And so that one is also not very difficult. And then what we have here in the fifth form, we have integral of x over x squared plus 3 cubed. Right. So that's just going to be minus 1 over 4 times 1 over x squared plus 3 squared plus c. Let's make that neat. Right. Now the last one, well, this one is a little difficult. Right. But we can still manage to do it. And, well, there's 2 ways to go about this. Right. Well, firstly, what we're going to do is we're going to complete the square here in the divisor. Right. So completing this square, that gives us integral of x over, right, that's going to be x plus 2 squared plus 1 dx. Right, now that already looks a lot better. Now in this case, you could either use a trig substitution, right, or you just make a little plan. Well, we'll see, we essentially have almost something like we have here, right, but not quite. So what we do is we do the following. Right? So we write this as a half plus 4 over x plus 2 squared plus 1. Right, now why am I doing this? Right, that is so that I have the derivative of the divisor here, the numerator. Right, that means that we're going to have ln. Right, it's going to be the integral of this term will be ln of x squared plus 2 squared plus 1. Right. Now see, I've added essentially a 2 here. Right, so I have to take that away. So I have minus 4 over x plus 2 squared plus 1 dx. Okay. So here I'm adding this 4 and here I'm taking it away. Right. And this, right, this is now just an octan form. Right. So what I have here is then a half ln absolute value x plus 2 squared plus 1 minus 4 arctan x plus 2 plus c. Right. So we've taken this expression, right, which really, we don't know what the integral should look like, and we've just manipulated it algebraically, right, to get it into the forms that we can integrate. Right. Now essentially, these are the 6 simplest rational functions that we have. Right. And we're going to look at techniques of taking a general rational function, right, and reducing it to forms a to f. Right. So in the next video, we'll look at how to do that.